Understanding the necessary clearances around electrical equipment, such as variable frequency drives, or VFDs, is crucial for ensuring safety and compliance with electrical codes. When installing or maintaining a VFD, especially in locations where space is limited, such as rooftops, it's essential to consider the proximity of grounded parts. A guardrail, in this context, is typically considered another grounded part. This classification significantly impacts the required working clearances. The National Electrical Code, or NEC, dictates the minimum working space required in front of electrical equipment operating at various voltages. These requirements are designed to provide sufficient space for electricians and other qualified personnel to safely inspect, maintain, and operate the equipment. The required working space is determined by several factors, including the voltage of the equipment and the presence of grounded parts on either side of the equipment. When other grounded parts are present, the NEC mandates a specific minimum clearance. For a 480-volt, three-phase system, the presence of other grounded parts on one or both sides of the VFD increases the required working space to 42 inches. This is to allow for safe movement and operation around the equipment. It is important to differentiate other grounded parts from exposed live parts, which would require even greater clearances. Other grounded parts typically include things like metal structures, grounded conduit, and, as in this case, guardrails that are intentionally grounded. These grounded parts present a potential hazard in the event of an electrical fault, and the increased working space provides an additional margin of safety. In situations where a guardrail is installed too close to the VFD, resulting in a reduced working space, several options can be considered. Firstly, the guardrail could potentially be relocated to provide the required 42-inch clearance. This might involve moving the guardrail further away from the VFD or modifying its design to minimize its encroachment in the working space. Secondly, if the location is not feasible, it may be necessary to move the VFD itself. This could involve relocating the VFD to a different location on the roof or modifying its mounting to provide the necessary clearance. Thirdly, in some cases, it may be possible to install a barrier between the VFD and the guardrail. This barrier would need to be non-conductive and designed to prevent accidental contact with the VFD live parts. However, this option would need to be carefully evaluated to ensure that it meets all applicable safety requirements and does not create any new hazards. It is crucial to consult with a qualified electrical engineer or inspector to determine the best course of action. They can assess the specific circumstances of the installation, including the voltage of the equipment, the presence of grounded parts, and any other relevant factors. They can then provide guidance on the appropriate clearance requirements and recommend solutions to ensure compliance with the NEC and other applicable codes. It is important to remember that electrical safety is paramount. Working on or around electrical equipment without proper training and precautions can be extremely dangerous. Always to energize equipment before working on it, and use appropriate personal protective equipment, or PPE, such as gloves and eye protection. In addition to the NEC, local electrical codes and regulations may also apply. It is important to be familiar with these requirements and to ensure that all work is performed in accordance with them. Failure to comply with electrical codes can result in fines, penalties, and potentially even injury or death. Therefore, it is always best to err on the side of caution and to seek professional guidance when in doubt. In summary, when installing or maintaining a VFD, it is essential to consider the proximity of grounded parts, such as guardrails. The presence of other grounded parts requires a minimum clearance of 42 inches for a 480-volt, three-phase system. If the required clearance is not met, several options can be considered, including relocating the guardrail, moving the VFD, or installing a barrier. It is crucial to consult with a qualified electrical engineer or inspector to determine the best course of action and to ensure compliance with all applicable codes and regulations. Always prioritize electrical safety and take appropriate precautions when working on or around electrical equipment. Now let's delve deeper into the NEC requirements for working space around electrical equipment. The NEC Article 110.26 covers the specifics of working space about electrical equipment operating at 600 volts, nominal or less to ground. It outlines the minimum clear distances required in front of electrical equipment, and these distances vary depending on the voltage and the presence of exposed live parts or grounded parts. The NEC defines 3 conditions for determining the minimum clear working space. Condition 1 applies where there are exposed live parts on one side of the working space and no grounded parts or grounded equipment on the other side of the working space. Condition 2 applies where there are exposed live parts on one side of the working space and grounded parts on the other side. Condition 3 applies where there are exposed live parts on both sides of the working space. In the case of a VFD installed near a guardrail, the guardrail would be considered a grounded part. Therefore, Condition 2 would apply. For a 480-volt system, Condition 2 requires a minimum clear working space of 42 inches. This distance is measured from the enclosure containing the live parts to the nearest grounded part. It is important to note that the working space must be clear and unobstructed. This means that there should be no equipment, materials, or other objects within the required working space. The working space must also be of sufficient width and depth to allow for safe access to the equipment. The NEC also specifies the minimum height of the working space. The working space must be at least 6 1/2 feet high or the height of the equipment, whichever is greater. This ensures that there is adequate headroom for workers to perform their tasks safely. In addition to the clear working space, the NEC also requires that there be an entrance to an egress from the working space. The entrance must be of sufficient size to allow for easy access to the working space, and the egress must provide a clear path for workers to exit the working space in the event of an emergency. The NEC also addresses the issue of illumination in the working space. Adequate illumination is essential for workers to be able to see what they are doing and to identify potential hazards. The NEC requires that the working space be illuminated to a minimum of 10-foot candles. This level of illumination can be achieved through the use of natural light or artificial light. It is important to maintain the required working space around electrical equipment at all times. This means that equipment, materials, and other objects should not be stored within the working space. The working space should also be kept clean and free of debris. Regular inspections should be conducted to ensure that the working space is being maintained in accordance with the NEC requirements. If any deficiencies are found, they should be corrected immediately. Failure to maintain the required working space can create a hazardous condition and increase the risk of electrical shock or other injuries. In addition to the NEC requirements, it is also important to follow any applicable local codes and regulations. Local codes may have more stringent requirements than the NEC, and it is important to comply with these requirements as well. When in doubt, it is always best to consult with a qualified electrical inspector or engineer. They can provide guidance on the specific requirements that apply to your installation and help you to ensure that your electrical system is safe and compliant. The installation of a guardrail near a VFD can create a challenging situation in terms of meeting the required working space clearances. However, by understanding the NEC requirements and by working with qualified professionals, it is possible to find a solution that ensures both safety and compliance. Now let's consider the specific case of a rooftop installation. Rooftop installations present unique challenges due to the limited space and the potential for exposure to the elements. When installing a VFD on a rooftop, it is important to carefully consider the location of the equipment and to ensure that there is adequate working space around it. The guardrail is often required on rooftops to protect workers from falling off the edge of the roof. However, the guardrail can also obstruct the working space around the VFD. In this situation, it may be necessary to relocate the guardrail or the VFD to provide the required clearance. Another option is to install a barrier between the VFD and the guardrail. The barrier should be non-conductive and should be designed to prevent accidental contact with the live parts of the VFD. The barrier should also be of sufficient height and width to provide adequate protection. It is important to ensure that the barrier does not obstruct the working space or create any other hazards. In addition to the working space requirements, rooftop installations also need to comply with other NEC requirements, such as those related to grounding and bonding. The VFD must be properly grounded to protect against electrical shock. The grounding conductor must be sized in accordance with the NEC tables. The VFD must also be bonded to the building's grounding system. This helps to ensure that there is a low impedance path for fault current to flow back to the source. Rooftop installations also need to be protected from the element. The VFD should be installed in a weatherproof enclosure to protect it from rain, snow, and other weather conditions. The enclosure should be rated for the environment in which it is installed. The enclosure should also be properly ventilated to prevent overheating. Regular inspections should be conducted to ensure that the enclosure is in good condition and that the ventilation system is working properly. Rooftop installations can be challenging, but by following the NEC requirements and by taking appropriate precautions, it is possible to install a VFD safely and in compliance with all applicable codes and regulations. Remember to consult with qualified professionals to ensure that your installation meets all the necessary requirements. Now let's discuss the implications of reducing working space. Reducing the working space around electrical equipment can have serious consequences. It can make it difficult for workers to perform their tasks safely, and it can increase the risk of electrical shock or other injuries. When the working space is reduced, workers may have to contort their bodies or work in awkward positions to access the equipment. This can increase the risk of muscle strains and other injuries. Reduced working space can also make it difficult to use tools and equipment safely. Workers may not have enough room to maneuver their tools, and they may be more likely to drop tools or accidentally contact live parts. In addition to the safety risks, reduced working space can also make it more difficult to maintain the equipment. Workers may not have enough room to perform routine maintenance tasks such as cleaning and inspecting the equipment. This can lead to premature equipment failure and increased downtime. Reduced working space can also make it more difficult to troubleshoot problems. Workers may not have enough room to access the equipment and to use test instruments. This can make it more difficult to identify and correct problems, and it can increase the amount of time required to repair the equipment. For all of these reasons, it is important to maintain the required working space around electrical equipment at all times. If the working space is reduced, it is important to take steps to restore it to the required dimensions. This may involve relocating the equipment, relocating the guardrail, or installing a barrier. It is also important to ensure that the working space is kept clean and free of obstructions. Regular inspections should be conducted to ensure that the working space is being maintained in accordance with the NEC requirements. If any deficiencies are found, they should be corrected immediately. Reducing working space is a serious safety hazard. It is important to take all necessary steps to maintain the required working space around electrical equipment at all times. Now let's talk about the importance of contacting the inspector. Electrical inspectors play a crucial role in ensuring the safety of electrical installations. They are responsible for enforcing the NEC and other applicable codes and regulations. When you are planning to install or modify an electrical system, it is always a good idea to contact the electrical inspector before you begin work. The inspector can review your plans and provide guidance on the applicable requirements. They can also identify any potential problems or violations before they occur. Contacting the inspector early in the process can save you time and money in the long run. It can also help you to avoid costly rework or fines. The inspector can also provide valuable information about local codes and regulations. Local codes may have more stringent requirements than the NEC, and it is important to comply with these requirements as well. The inspector can also answer any questions you may have about electrical safety. They are a valuable resource for information and guidance. When you contact the inspector, be sure to provide them with all of the necessary information about your project. This includes the location of the project, the type of work you are planning to do, and the equipment you will be using. The more information you provide, the better the inspector will be able to assist you. After you have completed your electrical work, you will need to schedule an inspection. The inspector will come to your site and inspect the work to ensure that it complies with the NEC and other applicable codes and regulations. If the inspector finds any violations, they will issue a notice of violation. You will then need to correct the violations and schedule a re-inspection. Once the inspector is satisfied that the work is in compliance, they will issue a certificate of compliance. This certificate is required before you can energize the electrical system. Contacting the electrical inspector is an important part of the electrical installation process. It can help you to ensure that your electrical system is safe and in compliance with all applicable codes and regulations.